Okay, so you guys should already know this if you went through it already. Discriminant is b squared minus 4ac, and when it's greater than 0, you know that the quadratic equation has two real and distinct roots. When it's equal to 0, it has two roots that are real and equal, and when it's less than 0, it has no real roots, but it has complex roots. You might see it might have it. The textbook that you see might not mention complex roots, but I think for now you can just say no real roots is fine. Did you guys work through this question already? Hello?
No?
Is that Kiana?
Yeah.
Okay, so you could just do this question quickly for me. Determine the nature of the roots of 5x squared plus 5x minus 2 equals 0. And if you feel stuck, you can just say so and I can just give you a hint. Or I could even just help along a little bit. Let me just... Remember, to find the nature of the roots, you need to identify what's A, what's B, and what's C. So this would be A, this is B, and this is C. Well, minus 2 is C. And from there, you can just work out the discriminant. So someone can give me the answer. Both the value of the discriminant and what type of roots the equation has.
It's 5 and it's real and this.
All right, let's see the answer. All right, you're right, it's real and distinct because the discriminant is positive. And here I just have a graph that I did using some graphing software. Can you see my cursor, or I'm curious? Is there a setting to... Can you see my cursor on the screen? My mouse? What?
Yeah.
Oh, you can see. So this is just a graph I did. And you can see, these are where the roots are. We didn't really have to calculate the roots per se, but you can see that there are two roots and they're in two different places and they're real numbers. This is like negative 1.3, about that. And this is like, if I had to like estimate, that's like 0.3, but we didn't have to calculate the roots, so that isn't the point. But it's just showing you that the roots are where the graph intersects the y-axis. So you can see it intersects the x-axis at 2 points here, A and B, and they're two real and distinct roots, like it says here. And it's the same equation that you guys just worked out. Any questions? Okay, I'll just take that as a no. Okay, so you guys can work out this one for me.
Real.
Just real?
I think it's
Pardon
no
me?
real. No real.
Hey,
Real.
your audio is a bit low. I could hear you before, but it's low again. But I heard real. So they're real and equal. I'm not sure if you said equal. Sorry. Because you get the discriminant is 0. So you know that the equation has 2 real and equal roots. And here's just the calculation. Right here. And the statement, since b squared minus 4ac is equal to 0, the equation has real and equal roots. And then on the next slide, again, I just have a graph of it. It's the same equation, just a 1x here, x squared here, but you know, that doesn't matter. Same thing as x squared. And you can see that it only touches the x-axis at one point, which is here, at this little a here. And before it was an a and a b, and it looked more like, you know, it was more like, let me just draw it. It was like this, but you know, smoother and better drawn. So now it's only touching at one point. So that's just what it looks like graphically. And yeah, just delete that. And here's another one. So you guys can also work out this one.
-4, and it's no real roots.
Yeah, correct. Yeah, and I just said note the word real because it does have roots. It just has no real roots. So here's what that looks like on the graph. And unlike the other two graphs, which were something like this and something like this, yeah, that's not great. but you get the point. This one touches the x-axis twice. This one touches once, but this green one that we just drew, we can see that it doesn't touch the x-axis at all, and that's why it has no real roots. Because the roots are, that just means the points where it intersects, the graph intersects with the x-axis. Everybody okay?
Yeah.
Yeah.
Oh, someone else joined? How many people are there now? It sounds like a different voice. Anyway.
6 people.
Oh, class. Welcome everybody. Started a little bit too early. Alright, let me just move on to the next slide. I think you all did this ready. Okay, so not sure if you have done this part, but I'll just ask anyway. So the question here is, why do you think that we don't have real roots when the discriminant is less than 0?
In like the quadratic equation, when finding the roots, we have to like square root it. We can't square root a negative. So
Yeah, correct. Correct. Yeah, and I was going to give you a hint, but you already figured it out. That you can't have a negative under the square root, and that's why. Because you can't get a real number from it, so it has no real roots. Okay, so now I have some questions that I'd like you to do. And it's just more, just reinforcing the topic, so you just find the nature of the roots for each of these equations. So someone can just give me answers for each one of these.
He went through these yesterday. Well, the first two. First one is negative 72, I think. Wait, was it? I don't know. Yeah, it was negative 72.
Correct.
So that's
You can also use, you'd also see in some textbooks that they have like a triangle for discriminant. I think that's more common in capital D, but I just put it as capital D for convenience while I was typing. But you might see triangle, and that's the same thing. Okay, so anybody finish the next one?
Zero and one distinctive root.
Correct.
third one is positive 64.
Well, I got 79.
Okay.
Let me just double check that. I don't know. Maybe I made a mistake here. Now I look at it again, it seems like it is 64. So that seems like a mistake. But it's still two real and distinct roots, so maybe that was for another question I had there before. Okay, so the next one.
negative 23.
Correct. No real roots.
Next one is positive 25.
And what are the roots? Remember, guys, you really should say the nature of the roots because that is what the question's asking for. So just remember to add that in.
2 real roots.
Real and
Distinct.
correct. And last one.
Next one is 145 with 2 real distinct roots.
Yep. Okay, so we have slightly harder questions here. Find values for k such that k squared plus 3kx minus 3 equals 0 has equal roots. So just remember, what does having equal roots mean? And how do you think we can find k in relation to the discriminant formula?
The real root would be, same root means that the discriminant is 0, so I think.
Right? So we can just say that this is b, this 3k is b, this here is c, and this, well, sorry, not that, but let's say a 1 is here, and that is a. So then we have b squared minus 4 ac equals 0. That'd be 3k squared and it's all squared. Just make sure you don't get that wrong. Minus 4 times a is 1 and c is negative 3. Also, don't make that mistake. Negative 3 equals 0. So then we get 9k squared plus 12 because we have negative 4 times 1 times negative 3. So that gives us positive 12. Interesting, this answer is a little funny looking. But we get k squared. This equation, I think this is supposed to be positive 3. Because then we get negative 12 on 9 square root. So this should be a positive 3. Just to make that work out. So let me change the question. I'm going to put a note to change that. But let's change this to negative just so it works out. Twelve on 9. And then we have therefore k is equal to square root of 12 on 9 and I would simplify this. Has anyone in this class done surds yet?
No.
Me.
Me too.
So you know that we can simplify this a little bit. We can write it as, let's see, we can write this as the top part as 2 root 3 on 3. I believe. I'm just doing that in my head. Yeah, 2 root 3 on 3. But if you guys haven't done surds yet, you could just leave it as this fraction here. And if you're writing in your notes, remember to change this to positive 3. So it works out. Or else we have a negative square root and we can't have that yet. Okay, so can I move on to the next question, or does anybody have a question? Any questions for me? And I said earlier in the session, I know everybody wasn't here, but I had said earlier, if you have questions, just please unmute because it'd be difficult for me to, go back into Discord and then look at the chat and then answer the question in chat there. And also I'm recording, so I don't really want to go back and forth between the presentation and Discord. So any questions, or are we all good? Okay, it looks like we're all good. I'm not hearing
I
anything.
think you're all good.
Okay. So can I just erase this? Or would you all like... I think what I'm going to do is, if you guys want answers to these questions, I'd probably do it in a separate thing and make it look better than this. I think I'm just going to erase everything for now. And I think there's a delete all. Yeah, I think I'm just going to erase everything at this point. Alright, so this second one, I really hope this one works out. Oh geez, I don't want another one that doesn't work out properly. Find values for p such that x squared plus p plus 3 x minus 5 times p plus 5 equals 0 has equal roots. So it's the same principle here. So you guys can work it out and tell me the answer. It's the same steps. You just have to identify what A, B, and C are, and basically you have it. That's the hardest part. Finding A, B, and C, and realizing that that's what you're supposed to do. Okay, so has anybody started to work it out yet? Not finished, but started?
Started.
How far did
I
you get?
started.
Standing brackets. Trying to stick up the p plus 3x. 5.
P plus
3x 5.
Sorry, I think you're cutting out. I can't hear that
I said
well.
I'm kind of stuck at p plus 3x.
Oh, so this whole thing, this P plus 3, all of this will
Yeah.
be B.
Oh. Okay.
If you think about it, right?
Yeah, I get it now.
Because it's just the coefficient. That's the trick. Like, you put in these brackets and it looks a little bit more confusing, but it's just all B. And this is all C, all of this here. All of this. So I was just working it out again, because some of these questions I just pulled from textbooks and such. But this one does not work out nicely. It does have real roots, but you know, it's not like whole numbers or anything. It doesn't work out that well. So let me just start working it out. It might not work out the whole thing. I might just leave it in the quadratic form, just show you how it works out to a point, and then you guys can work it out after. So this whole thing is B. So we have B squared, all of this squared, minus 4 times A is 1 again, and C is this whole thing, including negative 5, because C is just a constant, right? And then we have equals 0 because it has equal roots. Does everybody understand up to here? Like why our equation looks like this? Remember, there's no problem with speaking out if you have a problem. So everybody's good? Okay. So I'll just move on. P squared, so we're expanding these brackets here. P squared plus 6P plus 9 minus, alright, this whole thing here is going to be a little fun to expand because that is a whole mess. So let's expand in here first. We have negative 5P minus 25. Negative 5P.
I'm getting a decimal, like, before
Hello?
you finish. Getting a decimal before you finish. Like, I got negative 109 divided by 20.
You got what?
I have p squared plus 26p. Oh no, p squared plus p equals to negative 109 over 26.
Where do 6 come from?
Wait, 6 this 6P?
Yeah.
I just expanded here, so like normal like P plus 3 times P plus 3. So P squared, we multiply this by this, plus 3P, plus 3P, plus 9. I just shortened it, sorry. But I just did all of that in one step. I hope that's clear.
Fast.
Yeah. So that's how I got the 6. Everything else is good though. So this is minus 20.
Yeah.
Okay, there was someone saying that they had gotten the p squared plus 26p. Something like that.
Yeah,
Right?
but
That
then I
is
was trying to remove the 26 from the 26p, so you have the p on by itself. But
right.
when
So
you
you're on the
divide
right
it,
track. You're on the right track. You're doing the right
alright,
thing. So let me just get down there. He got 26p. I'm sorry. I feel like I'm skipping too many steps. Let me just stop myself from doing that. So p squared plus 6p plus 9. So we have negative 4 times negative 5p. So that's plus 20p. Just by distributive law, that's what that's called. Negative 4 times 100, which gives us, sorry, negative 4 times 25 gives us positive 100. And that's all equal to 0. And as somebody correctly told me, who was it that told me that? I don't know people's names. I'm sorry. If you want to give your name. So we have p squared plus 26p plus 109, because we add the 109 from over here, equals 0. Yeah, this is not fun to solve, but let's see.
yeah, I move over the 109, and then I tried to divide the 109 by the 26, but it's giving me a decimal. So
I think the easiest way is just to solve it as a quadratic again. So because it's in p squared plus 26p plus 109 equals 0. So you could just solve for p as a quadratic. Which seems weird because originally
can I
p was...
factorize it with the AC method?
Oh, I don't think you can factorize this. This isn't something that's obvious to factorize, I don't think. 109, 26. Is it factorizable? I don't think so. I'm
I'm
thinking...
not sure.
Yeah, I would just use the formula in this case to solve for p. So you guys can try to solve this quadratic, this p. So has anyone started to work out that last part, this equation at the bottom? Like even if you just leave it looking quadratic under the quadratic formula, you can just tell me what you got. because this equation here is kind of weird. You can simplify it, but you have to know thirds to simplify. And I don't know if everybody has been taught thirds at this point, which is a problem with odd math. Sometimes you need to know different topics to teach one topic, but I'll just avoid questions like these for now. So has anyone come up with anything?
I'm still working.
Okay, no problem. If you guys need me to explain anything, feel free to unmute and ask a question.
First one I got out 5.25, and then I can work out the second one.
What, 0.7?
5.25.
Right, that's correct. That's one of the answers. Well, negative.
Yeah.
And the other one?
-20, right? 0.7. So
Right, 20.7? That's what you
yeah.
said? Right, that's correct too. So, can I take this off? All of this off the board so I can like show how they got that part out? Or are people copying this? Still? Alright, I'll just erase. No one's objecting, so I'll just erase. Just so I can show how he got out that answer. If you haven't, let me just delete all. It was p squared plus 26p plus 109 equals 0. So using quadratic formula, we have p is equal to negative 26 plus minus square root of 26 squared minus 4 times 1 times 109 all over 2 times a, which is 1. Everybody okay so far? It's just using a quadratic formula because this is a quadratic. Right? So let me just simplify what's under the square root sign. So all I'm doing is finding, you can just put this in your calculator altogether actually. 26 squared minus 4 times 109 gives you 240. Over 2. And you have one of two options. So you can do what the person who gave me the answer, I don't know his name, did and put this in your calculator as is. Or you can use surds. And if you use surds and simplify, you should get, let's see, you would get negative 13 plus 2 root 15 or negative 13 minus 2 root 15. And these are the exact same things as what he told me. One is the negative 5.7, is it? 5.25. And the other one is negative 20. So if you don't know surge, you can just put this in your calculator and it'll just give you the answer. And if you do know surge, you can also write it like that. So is everybody okay with this? Any questions? So these are the values of P. Okay, I'm hearing silence, so I'll assume it's all good.
You understand?
You understand? Okay, great. Okay, so that's the end of all my slides on discriminants. I think I'll send you guys more questions like as homework, but I'm not keen on grading homework, so you guys could just do it for practice. How would you guys like it if I just sent practice questions, not for grading or anything, but just for your own knowledge, and I could send answers.
Yeah.
Right. So I wouldn't like make you hand it in or anything, because like why would I do that? It's more work for me. So I would just send some practice questions on this, and I would probably send some more of this kind of form because there are a few CAPE questions. Sorry, not CAPE. A few CSAT questions, AdMath questions that are like this. Not a lot, but a few. So you should just know how to solve them in general. So it's a little bit late, but I do have another topic in here, which is disguise quadratics. Has anybody out in here already done this in school as yet?
We did it yesterday in the last math class.
Oh, right. I forgot. And you guys wanted questions on negative indices? I know Josiah told me, but it was negative indices. He told me something like that. You guys wanted questions on something along those lines because they're disguised quadratics that use negative indices. Sometimes those come.
I think he said you were going to go through some of them.
Oh. Yeah, because I was looking for some because he told me last night, but I couldn't find a lot specifically on negative indices or anything like that. I mostly found some normal ones. So you guys went through these slides already. Solve the following equation.
Yeah.
So this one is a pretty easy disguised quadratic. This is pretty much the easiest that they come, I suppose, because it's obvious. These two powers have a difference of 2. You can say let y equal x squared and then substitute. So that'd be y squared minus 13y plus 36 equals 0. And what would be the answers for the equation? Somebody. Anybody?
To raise it now. Okay. And then by multiplying, by finding factors of 36, using the triangle 13.
Right.
I gotta think about that real quick though. So
All right, so we need two numbers. When they're added together, you get negative 13. And when they're multiplied, they get positive 36.
nine and 4.
All right, yeah, let me just write out the steps. So if we add negative 4 and negative 9 together, we get negative 13. And if we multiply negative 4 by negative 9, we get positive 36. So let me just write that like this in brackets, factorize. So then we get y equals 4 and 9. That's our solutions. But we're not done. We have to remember that we are originally solving for x. It's what we want to solve. Y is just our substituted thing. So we have to remember, what we're solving for. So if we remember that we said this earlier up, we can just say 4, which is y is 4, is equal to x squared, which is from up here, nothing new. And we also have 9 is equal to x squared. So then we have x equals plus or minus 2, x equals plus minus 3. All right. Everybody good?
Yeah.
Yeah.
All right, I'll just take this off. Yeah, they just solved it over here. And I remember when you do these disguised quadratics, I remember when I was doing odd math, I would always forget to, I was solving for x and just leave it here with the solutions for y, but you have to go back and remember that you're solving for x or whatever original variable it was, so don't lose marks that way. I know I have some questions on this day's quadratics. This one looks terrible, but I'll just rewrite that. So for number 1, can someone tell me, not the answer, but just how you think we should start out?
Make it equal to 0.
Right? Makes sense. We want to get it into a form that we're familiar with. So then we have this plus 24, because we move it off, it becomes positive, equals 0. Now, what do we do next?
Y is equal to the square root of x.
Right? Let y equal root x. So then we can say that y squared, because this is x, so if we square root x, we get x. So if we square y, we get x. Wait, what? Confused myself there. Sorry. If we square root x, square root x, we get x. So therefore y squared is equal to x. Yeah, I said it incorrectly before, sorry. So we get y squared minus 10y plus 24 is equal to 0. And this is a more familiar form. So someone could just, look at it and tell me what you think are the, how we can factorize this. All right, I'll just move along because we're running a little low on time. So I'll just y minus 4 y minus 6 is equal to 0. So therefore we have y is equal to 4 or 6. So for x, what we would do is that we have, remember, root x is equal to y, so we can say root x is equal to 4, root x is equal to 6, and as we square both sides, we get x is equal to 16, and we get x is equal to 36, and those are our two solutions. Alright, so that's one of the easier questions. So, right, I heard you guys want negative indices, so like things like this negative 2 power thing. So I looked for some questions on that and I found these 3. So I'll just go through these quickly. I know it's getting close to 5 o'clock, but I'll at least go through one. So for number 2, what we can do is we can also set this one equal to 0. So I think that's the first thing we should do. 7x to the power of negative 2 is minus 8x to the power of negative 1 plus 1, because we're bringing over the negative 1, is equal to 0. So what we can do in this case is we can let y equal x to the power of negative 1. So we can say 7 times y squared, because x to the power of negative 1 squared, of course, is just the same thing as x to the power of negative 2. If you remember your indice laws. So we have 7y squared minus 8y plus 1 is equal to 0. So we need two numbers. When they're added together, we get negative 8. And when they're multiplied, we get 7. So that would be negative 7 and negative 1. So let me just write this out. 7y squared minus 7y minus y plus 1 is equal to 0. So we can just start to factorize this. We see we can factorize 7y. So this would be y minus 1 easiest thing to do here is factor out -1. So then we get y minus 1. So then we have 7y minus 1 y minus 1 times y minus 1 is equal to 0. And we have, I'm just going to write over here, just going to come over here, y is equal to 1/7 or 1. And then from there to find x, we go back to here. So remember we let y equal to x to the power of -1. So what that means is x to the power of -1 is equal to 1/7. And x to the power of -1 is equal to 1. So from here we know that x is equal to 7 and x is equal to 1. Any questions?
Can you explain exactly what happens when you transpose the negative component over to the next side of the equation?
You mean up here?
No, I mean, when we're doing x to -1 equals 1/7.
Oh,
What happens? Transpose the -1.
okay. So I think you guys did indices, a little bit of indices in third form, I believe. So there is this indice rule that if you have, let me erase, I don't want to use 7. If you have x to the power of -1, that is the same thing as 1 over x. And basically what I'm saying there is 1 over x, because I have x in -1 over here, is equal to 1 over 7, right? Following?
Yes.
So, I mean, we can just cross multiply. Multiply this side by x, multiply that by 7, and we get x equals 7, right? Okay?
Yeah.
Yeah. Let me just put this in a box. So I should have made that a little bit more clear as I explaining. But hopefully you can just write that down so you remember. And I did the same thing for the 1 over here. So that same thing, that same process. So just remember x to the power of -1 is equal to 1 on x. So you can just break it down like this. So it makes more sense to you. Any more questions?
Could you just show me how it would be done if the component was not -1, like a different component?
Okay, that's a good question. Can I erase up here? If anybody's copying, I don't know. I want to erase this top part with the... Hey, you're still copying?
I already copied it.
Okay, so I'm just going to erase this part here. If you don't have it, you can just go back to the video because I'm recording. Ugh, it's so annoying. So if we have a power that is not -1, let's say we have -8. This is the same thing as this. Right? So, I don't know. Should I say if we had it in this instance? So you want to know how I would solve it if it was x to -8 is equal to 1/7? You want me to use Latin
Yeah.
1/7? Okay.
Yeah.
So for this one, what we would have to do is say 1/x to the 8 is equal to 1/7. So it'd be a similar process. We cross multiply. So then we get x to the 8 is equal to 7. So then we get 7. 8 is a bad number, but you know, we get the eighth root of 7.
Okay, I understand now. Thanks.
No problem. Just remember to copy this so you remember. And I think I'm just gonna stop here for the day. I know there's like 2 more questions here. But what I might do is just send them in the chat and send answers. And then you can just do them on your own. And if you have any problems, my office hours are Saturday